Hello students, welcome back to lecture 2 of number system. This is Vyasa IAS CSAT course and we are moving in our lecture 2. Now see students, I hope you find the last lecture interesting. Now let's move on to the second lecture. So in the last class we studied basically two concepts. The first is of representing any number, that any number on the number line, basically if it is an integer, it can be represented in the form of multiple of any numbers. For example, if we are taking 2 as a number whose multiple have to be every number, so basically each number can be represented in the form of 2n and 2n plus 1. Basically what I am trying to say is that any number in the number line can be represented in the form of either 2n or 2n plus 1. And similarly, any number in the number line can be represented in the form of 3n, 3n plus 1 and 3n plus 2. I also explained the meaning of this term, that basically what is this? For example, let's take any number, let's say 7. So basically 7 is what? 3 into 2 plus 1, that is, it is in the form of 3n plus 1. Okay, so that means whenever we are going to divide 7 by 3, the remainder is going to be 1. So basically this one is what? Remainder. This one is remainder. Okay, so when we will see the remainder theorem, that will become more clear, much more clear to all of you. But I think this much concept must be clear for all of you. The next we saw was the concept of decimal. And there were some questions in the handout that were there for converting those decimal number into fractions. The trick was very simple and I think everyone must be able to do it. Now see, let's move on to a bit trickier concept. Now see student, at the outset of this course I will declare one thing, that UPSC CSAT is very different from other aptitude tests in that, because in UPSC CSAT whatever are the properties of the number system, that you have to interpret. Okay, that you have to interpret. So for that you have to know the properties of the number system. Okay, you have to know the properties of the number system. So in this class we will be studying a lot of properties. Okay, so this will be more like a theoretical class than a numerical class, but in this class we will study more of the properties. When we will have 2 3 more concept, then we will solve conjoint questions of the concept, that is a question in which 2 3 of the concepts are applicable from this number system. Okay, so now let's just devote this class to studying of property. Now see, for some of you this can be boring, but try to pay attention to each and every property what I am saying. So that will bring clarity to you and it will increase your tendency to apply these concepts in the coming questions. All right. So we will be doing a lot of question, but not in this class. We will be doing a lot of question in from the next class, because uh, from the next class, most of our concepts will already be done and we will be able to solve a lot of number system questions. And if you have seen the CSAT paper, you know most of the questions are from number system. Okay, so you will be able to solve most of the question from the number systems. Okay, so now let's begin this class now that I told you. Okay, see, in this class, basically, we are going to study the number system once more. What we are going to study? See, basically, we are concerned here in aptitude with real numbers. In aptitude, there is mostly no application of imaginary numbers, okay, or complex numbers. Okay, so आप में से जो भी लोगों ने 11th और 12th मैथ से किया होगा तो उन्हें इमेजिनरी नंबर और कॉम्प्लेक्स नंबर के बारे में पता होगा, बट दैट इज नॉट एप्लीकेबल हियर. द कॉन्सेप्ट ऑफ रियल नंबर इज एप्लीकेबल हियर. नाउ सी, real number can basically be divided into decimal and integers. All right. And decimals, last class we saw, they can be finite or terminating decimals, and then they can be infinite or non-terminating decimals. Okay. And these decimal, infinite and non-terminating decimals can also be written in the form of P and Q. Okay, but there are some numbers which are infinite and non-terminating and non-repeating as well. Okay, they are infinite, non-terminating and non-repeating as well, and they cannot be written in the form of P and Q, so these are known as irrational number. All right, so real number, first we are giving two divisions of real number, that is decimal and integer. In decimal, you will have finite or terminating decimal, and in you will have infinite or non-terminating decimal. So finite and terminating decimal, definitely they can be expressed in the form of P by Q. And we saw how to express any number in the form of P by Q, that is given in the decimal format in the last class. And then you have finite or non-terminating decimals. So finite or non-terminating decimals, when they are infinite but they are repeating, so they can be represented in the form of P by Q, whether pure or impure. But when they are infinite and non-terminating and non-repeating, they cannot be written in the form of P and Q. Okay, now I hope everybody must be clear with this concept. Now let's move forward. Now see, integers are those numbers which have no decimal. In the last class, I told you that the definitions of the number are dependent on each other. For example, decimals are those numbers which have which are in the decimal format or which are not integers, and integers are those numbers which are not decimals. Okay, so see, number having no decimals are known as integer. So you have 0, okay, you have negative integers and you have positive integers. Okay, and 0 plus positive integer are known as non-negative integers, and negative integers plus 0 is known as non-positive integers. I hope everybody must be clear with this concept. Okay, and see, positive integers are basically equal to what? Natural numbers. So basically 1, 2, 3, 4 are all positive integers, and those are same as natural numbers. Now see, natural number can be divided into three. Okay, three divisions. Uh, there is unity, and then there are prime numbers, and then there are composite numbers. See, unity is 1. Okay, prime number is a number which is not divisible by any other number other than itself and 1. But see, 1 is not a prime number. Remember, 1 is not a prime number. And then you have composite number. So what are composite number? That are divisible by uh, numbers more than itself. Okay, I mean that composite numbers are the numbers that are divisible by numbers other than itself. Okay, so for example, there is 8. So 8 is divisible by itself, and 8 is also divisible by 2, and 8 is also divisible by 4. So composite number are those numbers which are actually composed of other number. Okay, so that is why it is known as composite. Okay, so for example 25, yes, it is composed of two fives, so it is known as composite number. So I hope this is very basic. This is what we learned in our primary classes. So I hope everybody is clear with this thing. Now let's move forward. Now see, students, let us see prime number more closely. Now see, a prime number is a natural number larger than unity, and it does not have other divisor except for itself and unity. And remember that unity is not a prime number. So I know everybody of you must be familiar with what a prime number is. You know, 1, 3, 5, 7. All these are what? Prime number. 11 is a prime number. 13 is a prime number. 17 is a prime number. So you all know what prime number is. Okay. But now let us see the properties of prime number. Alright. See, the first property is that the lowest prime number is 2. Okay, unity is not a prime number. The lowest prime number is 2. And also 2 is the only even prime number. Okay, remember this, 2 is the only even prime number. And the lowest odd prime number is 3. So remember this thing also, that lowest odd prime number is 3. Now see students, look at this property. It is saying that the remainder when a prime number p is greater than 5 is divided by 6 is 1 or 5. Okay. So what it is saying basically, that you take any prime number greater than 5. Then let us take 7, and 7 when it is divided by 6 it is giving remainder 1. Now let's take another prime number. Okay, so we have 11 as another prime number. Divide this by 6. What is the remainder? You are going to get 5. So see, we get one way to check whether any number is prime or not. That is, divide that number by 6, and if you get the remainder 1 or 5, then there is a possibility that it is a prime number. Okay. However, if a number is being divided by 6, give a remainder of 1 or 5, the number need not be prime. Okay, so if this condition is satisfied, then also there is a possibility that the number is not prime. So this is a necessary condition but not a sufficient condition. Okay, what I am trying to say is that कि अगर कोई नंबर ऐसा है जिसको डिवाइड करने से 6, जिसको 6 से डिवाइड करने से 1 या 5 आए, तो ये पॉसिबिलिटी हो सकती है कि प्राइम नंबर हो वो, ठीक है ना। बट स्टूडेंट, अगर कोई प्राइम नंबर है और अगर हम उसको 6 से डिवाइड करेंगे तो ये 1 या 5 आएगा, इसकी पॉसिबिलिटी पूरी है। ओके, सो आई think now everybody is clear with this thing, that this is a necessary but not the sufficient condition. For example, let us think about any number that when divided by 6 gives a remainder 1 or 5. Okay, so now let's take this 13. Okay, 13 when you divide it by 6 you will get the remainder 1. 14 when you divide by 6, obviously you are going to get remainder what, 2. 15 when you divide by 6, again 3. Okay, 16 when you divide by 6 you will get remainder 4. um 17 when you divide by 6 you are going to get what, remainder will be equal to what, 5, and we know this is a prime number. Okay, 18 when you divide by 6, this is completely divisible. 19 when you divide by 6 you are going to get what, remainder 1. Okay, 20. So this goes, so definitely this is applicable, but when you will check the higher numbers, then this will not be the sufficient condition. Okay, this will not be the sufficient condition. This is a elementary condition. So for example, if you are given any number, let's say 243. Okay, now if the remainder is coming 1 or 5, then there is a possibility that it can be a prime number. So divide this by 6. What are you getting? You are getting 4 here, and the remainder you are going to get 0. Sorry, 3. Okay, the remainder you are going to get 3. So we know definitely that this is not a prime number. Okay, we definitely know that this is not a prime number. So this is a good check whether a number is prime or not. Okay, this is a good check whether a number is prime or not, because any prime number will satisfy this condition, but any number that satisfies this condition is not necessarily prime. I hope I am clear to everybody that any number that satisfies the condition that if p is greater than 5 and it is divided by 6, any prime number when it is greater than 5 and it is divided by 6, if it gives the remainder 1 or 5, then it can be a prime number. Okay, it can be a prime number. So for example, let us take for example 240, um, 245. All right, 245. So what is this? You will get 4 here, 0 you will put here, and 5 you will get as a remainder. Okay, so there is a possibility that this number can be prime. Okay, this number can be prime. But guys, we know that this number is not prime. Why? Because its last digit is 5, and any number whose last digit is 5 is divisible by 5. So now we know what we mean by this, that this is a necessary condition but not the sufficient condition. Okay. So see, here it was visible to us that this is not a prime number. Let's check some other prime number. Okay, let's check some other number. So let's see this 246 as well. So this is completely divisible. Let's check 247. Okay, 247. So again, you are going to get what's 24. You are going to get 1 here. So you are going to get 1 as a remainder. So now there is a possibility that 247 is a prime number, because see, we are not going to get any divisors. Okay, we are not going to get as any divisors. So this is how, what we mean by this concept. This condition is definitely very handy in checking whether a number is prime or not. I hope I am clear with this thing. Now let's move forward. See, the remainder of the division of the square of a prime number greater than 5 divided by 24 is 1. Okay, so basically what it is saying, um, that uh, any prime number which is greater than 5, if we square that prime number and divide that number by 24, so remainder will always be 1. Okay, remainder will always be 1. So now let's see any prime number greater than 5. Okay, so I have listed here the prime numbers. Okay, so let's take 7 as the prime number. Divide this by 24. Okay, so this is 49. Divide this by 24. What are you going to get as a remainder? 1. Okay, the remainder will be 1. Okay. Um, and see, for prime number p greater than 3, p square minus 1 is divisible by 24. Okay, so what is the prime number greater than 3? See, 5 square minus 1. So that means what? 24, and this is divisible by 24. You can check this property for any number. Okay, you can check this property for any of the number. So 7 square 1 is also 48. That is divisible by 24. And let's check for 11 as well. 11 square minus 1 is what? This will be 121, and this will be minus 1. So this is 120, and divide this by 24. Definitely it will go 5 times. Okay. So these are the properties, but these are all the necessary but not the sufficient condition. Okay. So the remainder of the division of a square of prime number, that is what I meant here, was that you take a prime number, square it, and then divide it by 24. You will always get the remainder 1. Similarly, take a prime number, square it, subtract by minus 1, and divide it by 24. You will always get a completely divisible number. Alright. Now see, students, since we are aiming for CSAT, let's just at least see what all the prime numbers are between 1 to 100 and 100 to 200, so that whenever we encounter these numbers, we don't have to do much calculation. Okay, so I think till 29, everybody is aware what are the prime numbers. Then you have 31, 37. Then you have 41, 43, 47. Then you have 53, 59, 61, 67. Okay. Then you have 71, 73. Then you have 79, 83, and 89, 97. Okay. See, so most prime numbers between 1 to 100. See, we are taking this generalization only between 1 to 100, have at their unit digit either 3, 9, 1, 7, 1. Okay, so 1, 3, 7, 9, whenever it occurs at unit digit, uh, between 1 to 100. So definitely there is a possibility that they can be prime, but again, you must be knowing the tables of so many numbers, so you will come to know automatically which number are prime. Right. सो सिमिलरली आप 100 से 200 के बीच के भी नंबर थोड़ा देख लीजिए कि विच आर प्राइम एंड विच आर नॉट. अगेन, अगर 3 है, लास्ट में 9 है, 1 है, एंड जब हम डिविजिबिलिटी टेस्ट देख लेंगे तो बेसिकली आप कुछ नंबर देखेंगे, आपको पता चलने लगेगा whether they are prime or not. All right. So this is about it. Now let's move forward. Now see, um, look at this. If a and b are two odd prime numbers, then a square minus b square is composite. Also, a square plus b square is composite. So what it is basically saying that अगर आपने कोई भी दो प्राइम नंबर ले लिए जो ऑड है, यानी आपको टू को इंक्लूड नहीं करना है बिकॉज टू भी एक प्राइम नंबर है, तो बस डोंट इंक्लूड टू, तो आपको जो इसको ए स्क्वायर माइनस बी स्क्वायर मिलेगा वो एक कॉम्पोजिट नंबर होगा. So let's see whether this is true or not. Let us keep a is equals to 5 and b is equals to 7. Okay. So a square minus b square will put, let's say 5 square minus 7 square. Okay. So this will be 25 and this will be what? 49. What is the subtraction? 24 minus 24 you are getting. So this number is composite. Obviously we know कि ये जो number है इसके बहुत सारे factors हैं, 2 है, 3 है, 6 है, 12 है, ठीक है, ये सारे इसके factors हैं, तो definitely ये जो number है ये composite number है, ठीक है. सिमिलरली आप 25 और 49 को अगर ऐड कर देंगे, ए स्क्वायर प्लस बी स्क्वायर भी कॉम्पोजिट बोला है, तो आपको क्या मिल जाएगा यहाँ पे? यू विल गेट व्हाट? दिस विल बिकम 4, दिस विल बिकम व्हाट? 6 plus 7, 74. We definitely know 74 is a 74 is a composite number. Okay, so this is what? 37 into 2. So this is also a composite number. So I hope everybody is clear with this thing. Now see the but this one of these should not be 2. Okay, it is clearly said here that if a and b are any two odd prime numbers, then a square minus b square is composite. Also a square plus b square is composite. Okay, so I hope everybody is clear with this thing. Now let's move forward. Now see, the remainder of the division of the square of prime number p greater than 5 divided by 12 is 1. Okay. Now what this is saying is that the remainder of the division of the square of a prime number p greater than 5 divided by 12 is 1. Okay. Um, so basically it is saying that we have any prime number p greater than 5, okay, and whenever we are squaring this number and dividing this number by 12, we will get what? The remainder will be always 1, okay. So you can obviously see this. Take 7 square, it is equal to 49. Divide this by 12. What are you going to get the remainder? 1. Take 11 square because it is also a prime number. 121 will be its square. Divide this by 12. What you are going to get? Remainder 1 because 12 into 10 is 120 and so the remainder is 1. Similarly, take 13 square. What is 13 square? 169. Divide this by 12. Obviously 168 is divisible by 12. Okay, 168 will be divisible by 12. So uh, what will be the remainder? 1. Obviously 1. All right. So this is what this thing means. Obviously again I am saying that this is not the uh, sufficient condition. This is one of the necessary condition. Okay. So why you must be saying that you told us one this condition, and this condition when it is necessary condition. So if the question comes that whether this number is prime or not, okay, whether this number is prime or not, I will check with this condition, and if this doesn't satisfy, I will say that it is not prime. Okay, but see, sometimes these kind of conditions will be given in the question and then you have to guess whether it's a prime number or not. So they will definitely give you hint to the question. All right. You will not find very specifically question on this, but they will be applicable within some other question. Okay. So here we are just focusing on the properties. Okay. Now see, to check whether a number is prime or not, what you have to do is take the square root of that number. Okay. and then after taking the square root of that number, round the square root of that number to immediately the higher integer. So basically, in this example, we have 181. Okay, take the square root of this number. Now see, we know that the square root of 13 is what? Is 169. Alright, is 169. What is the square root of 14? So 14 square root is what? 196. Okay, 196 is the square of 14. Okay, so now this 181 will lie between the square of 13 and 14. Okay, so its square root will also lie between 13 and 14. Okay, I hope everybody is clear with this. Let me explain one more. We are trying to find whether a number is prime or not. So to do that, first step is to take the square root of that number. Okay, so see, if we are trying to find whether 181 is prime or not, so what we are going to do is we have to take the square root of this number. Okay, now see, to find the square root, we are not going to find the exact square root of this. We will just take some approximation. Okay, so like we know that the square of 13 is 169 and square of 14 is 196. So square root of this will be what, 13 point something. Okay, whatever it may be. So let us consider a value 14. Okay, take some value 14. Now check for the divisibility of the n, means for 181, check the divisibility of the number n by all prime numbers below z. So if there is no prime number below the value, below this value, then this will be a prime number. Okay, so what this is saying, that we will check all the prime numbers below 14. So what are the prime numbers below 14? 2, 3, 5, 7, okay, 11 and 13. Okay, so we know this number is definitely not divisible by 2, because divisibility test of 2 says that your last digit should be an even number or 0. So definitely this is not divisible by 2. This is not divisible by 3 as well, because divisibility test of 3 says that this one, the sum of the digit should be divisible by 3. So the sum of digit is here 10 and it is not completely divisible by 3. This is also not divisible by 5, because we know that the last digit should be 5 or 0 to be divisible by 5. So again this is not divisible by 5. Now let's just check the divisibility by 7. Okay, so what are you going to get here? 7 twos are 14 and you have 41 here. So we know that this is not divisible by 7 as well. Now let's check with 11. Okay, so what are you going to get? 11 you are going to get once. Okay, 11 you are going to get once, and then you are going to get 71. So this is not definitely divisible by this. Now our last bet is 13. Okay, our last bet is 13. Now let's see whether this is divisible by this or not. So take this 13 one times, okay, and then it will be left with 51. Now see whether we will have 51 in the table of 13. So 13 ones are 13, 13 is 39. We know 13 4 is what? It is obviously 52. So we know 51 will not be occurring here. Okay. So definitely this 181 is not divisible by 13 as well. Now we can declare that this 181 is prime number. Okay. So now because you don't know the divisibility test, it may be a little bit difficult for you. Okay. But as we practice more, definitely we will be able to do this very easily. So now let's just revise this method shortly once again. So for example, if I have to determine whether 181 is a prime number or not, what I am going to do is that I will take its square root approximately. And how I am taking this square root approximately? Because I know that it is 169 is 13 square, 14 square is 196. So I will keep, I know that this square root will be 13 point something. And so I'll take the number 14. I will see all the prime numbers below 14, then I'll get 2, 3, 5, 7, 11, and 13. And then all these numbers I checked very easily because I know the divisibility test. Okay, 7 has a divisibility test, but it is not so easy to check. You can just divide for this number. Okay, so you came to know that this is not divisible by 7, this is not divisible by 11 as well, and this is not divisible by 13 as well. So this number is definitely prime. Okay, so this is how you check it. Okay, this is how you check the number. See now, the question came about square root. So I said I know the square root of square of 13 and square of 14. But see, I would advise you to just go to the square of at least first 33 numbers. Okay, first 33 numbers. So it is not very difficult. I think everyone must be familiar with the square up to 15. Just go through these numbers. Okay, just take this table and go through it again and again. So you will be able to remember what the square of these numbers are. Okay, but if you are not able to do that, definitely we will see some short tricks by which we can find the square of these number. All right. So guys, look here. Mm, this is all the table. Obviously, you can't remember all these things. I would just advise you that at least till 30, if you are able to know the squares, a lot of calculation will be saved. And see, in UPSC CSAT examination, those questions don't come where you require a lot of calculation. Okay, definitely, I can vouch for this. UPSC will not want you to calculate more. It will want you to have more analytical bent of mind and more mind that can see a very small and minute things in the examination pressure. Okay, so that is what UPSC is all about. Still, we will see how these calculations can be done because this course should also help you in other examination as well. Okay, so let's just begin. Now, see, we are seeing the trick for all the squares between 51 to 80. Okay, so this trick is applicable for all the squares between 51 to 80 only. So I hope everybody is clear with this thing that whatever we are seeing in this trick, this is applicable to the square between 51 to 80. Now see, to solve by this method, you should have the memory of first 30 squares. All right. So now let's see what the method is. Okay. So for example, you have to find the square of 76. Okay. 76 square. So do one thing with this. In the step 1, do 76 as 50 plus 26. Okay, do 76 as 50 plus 26. Now take the square of 26. So if you see that table, you will come to know that this 26 square is 676. Okay, this 26 square is what? 676. Now see, just write these last two digit as the last two digit of our final number of square. Now what about the first two digit? Okay, what about the first two digit? So just take this 6 as carry over, okay, and add 6 to 26, okay. plus add 25 more to it. Okay, so you will, whatever this number will be, that will be the square of 76. So what is 26 plus 25? Definitely it is 51, plus 6 it will be 57. So finally the square of 76 comes to be 5776. Okay, so this is basically for the square between um, 51 to 80. Okay, this is particularly for 51 to 80. So let's just see one more number whose square we are going to do. Okay, now see, we did use this table. Okay, for the first 30 square, because we required 26. Okay, we required the number 26. Now let's just see one more number between 51 to 80 whose square we are doing. Okay, let's take for example um, 67. Okay, 67. Now 67, write it as 60 plus 70. All right, now do the square of 17. So what is 17 square? It is 289, I guess. Okay, now write this 89 as the last two digit of a square. Take this 2 as carryover. Add this 2 to 17 and add 25 to it as well. Okay. So what are you going to get? 19 plus 25, which is equal to what? This will become 4 and this will become 4. So 4489. Now 67 square is 4489. Too easy to do by this method if we remember these principles. So let us see whether 67 square is what? See, 4489. So we successfully learned the method to take out the square of 51 to 80. What are we going to do? First, we will write the number in the form 50 plus whatever the number is. We will take the square of this x, and whatever will be the last two digits, we will write them as our square. Whatever will be the carryover, we will add them into this number x, plus we will add 25 to it and we will get our square. Okay, so this is the method. Now let's see the square for other number as well. Okay, now see square for numbers from 31 to 50. Okay, square for numbers from 31 to 50. So 31 से 50 के बीच में अगर नंबर है तो उसका स्क्वायर निकालने के लिए करना क्या पड़ेगा? ओके, सो लेट्स सी व्हाट वी कैन डू हियर. सपोज 41 का स्क्वायर ले रहे हैं. ओके, 41 का स्क्वायर ले रहे हैं, ठीक है ना. तो जैसे पहले कर रहे थे वैसे ही करना है, बट यहाँ पे 50 से माइनस कर देना है. वहां पे 50 से प्लस कर रहे थे, यहाँ पे 50 से माइनस कर रहे हैं. ओके, उसके बाद क्या करना है, आपने जो भी डिजिट माइनस की उसका स्क्वायर कर दीजिए. सो 9 का स्क्वायर 81 हो जाएगा. ऑल राइट, तो 81 हमारी लास्ट टू डिजिट हो जाएगी. ओके, 41 के स्क्वायर की लास्ट टू डिजिट 81 हो जाएगी. अब ये फर्स्ट के टू डिजिट्स के लिए क्या करें? ओके, तो बेसिकली क्या करिए, 25 से ये 9 माइनस कर दीजिए. वहां हम 25 से प्लस कर रहे थे जब हम 51 से 80 के बीच का स्क्वायर देख रहे थे. ओके, जब जब हम ये वाले स्क्वायर्स देख रहे हैं तो बेसिकली हम क्या कर रहे हैं, 25 से 9 को माइनस कर रहे हैं तो 16 आ जा रहा है. ओके, अब देखिए इसमें तो कुछ कैरी ओवर करने को है नहीं, तो हम 1681 लिख देंगे. ओके, तो 41 का स्क्वायर 1681 आ जाएगा. अगर आपको मल्टीप्लाई करके ज़्यादा जल्दी आ जाता है वो कर लीजिए, बट इफ़ यू कैन रिमेंबर दीज ट्रिक्स दिस इज वेल एंड गुड. ओके, सो लेट्स जस्ट फाइंड द स्क्वायर ऑफ वन मोर नंबर बिटवीन 30 to 31 to 50. Okay, 31 to 50. So let's just see for, let's say, 48 seems to be a bulky number. Okay, now what are you going to do here? Just do 50 minus 2. It will be what? 48. So let's So let's just check for another number. Let's just check for 48. Okay, let's just check for 48. So what we are going to do here, our method is what? 50 minus 2 will be 48. Okay, let's just do 2 square. 2 square is 4, but we need the last two digit, so we will write 04. Okay, now what we have to do, just subtract 25 minus 2. So this will be what? 23. So your square will be 2304. So this method is that simple. Just learn that this is just for 31 to 50. Okay, take any number, you are going to get square. Like just let's just say, take 37. All right, 37, what are you going to get? Um, in this, basically, just subtract 50 minus 30. Let's just take 37. Okay, so what we are going to do about 37? Let's just subtract 50 minus 13. So I think you will get 37. All right, 50 minus 13 will be 37. Now what we are going to do, just do the square of this. Okay, we will get what? 169. So you will have 69 and 1 here. Okay, all right. And now what are you going to do? uh, so just 25 minus 13, this will be equal to what? 12. Okay, 12. And there is one more number, so this will be 1369. So 37 square will be 1369. Let's just check whether it is or not. So you can see here 37 square is 1369. Okay, so try to see this part again and you will memorize the method, and then you can obviously apply it to find the squares. Okay, so these tricks are always helpful. All right. So I told you about the square of 37 or 36 that will be calculable in a similar manner. Let's just find the square for this also. So you have 36 square you want to do. So how you are going to do? 15 minus 14. Okay, that will be equal to 50 minus 14, that will be equal to 36. So what is the square of 14? You have 196, you have 1 as carryover. And what is 25 minus 14? You have 11 but plus 1, so you have 12. So 1296 is the square of what? 36. So square calculation is so easy if you just use this method. Okay, there you have to do 50. So let's just summarize these two. Here we are doing 31 to 50, and here we are doing 51 to 81. So when we were doing these number, so here what we did, we subtracted any number by 50 to make the number that was occurring between this number. Okay, then we squared this number, kept its last two digit as the two digit, and then we subtracted 25 minus x, put it here. If we got carryover, then we add it. Okay, here what we did was, we took in the form of 50 plus x. Again we squared the number, kept this number's last two digit as the last two digit. Okay, and then what we did here, 25 plus x of this number plus whatever the carryover came. Okay, so this is the summary of those methods. Now let's just move on to another one. Okay, now you have any number. See, we did it from 51 to. So what are you going to do here next is that, take the first two digit. Okay, so basically we did 182 is equals to 100 minus 18 is equals to 100 minus 18. Okay, we got this. Now what we have to do here is that 82 minus 18 plus 3. Okay, So what is 82 minus 18? You will be getting 64 plus 3 is 67, and then you have 6724 as your answer. All right. Let's just check it for 87 as well. 87 as well. So uh, what is for 87? Now see how you will find the square for 87. All right, so just subtract this from 100. Okay, subtract this from 100, you will be getting what? 13. Okay, do the square of 13 is equals to 169. Again you will get 69 as the last digit. Put 1 here. Okay, now you will do what? 87 minus 13 plus 1. What is 87 minus 13? You will get 4, and you will get 7 here, plus 1 will be what? 75. So you will get 7569 as the square of it. Okay, so now basically we got third method as well. So between 81 to 100, basically your approach should be that take the difference of the number. For example, you took 82, take the difference of the number. What did you get here? 18. Square it, write the last two digits at the square of the number, then do what? Take this number, subtract 18 from this, add whatever the carryover will be there, and then write the first two digit. So this is how you do the square. So I think how to find the square is now very simple for you. Okay. Now see, let's study some of the properties of the square. So when a perfect square is written as the product of its prime factor, each prime factor will appear an even number of times. Okay, so this is very clear. For example, let's say 169. Okay, so this is a perfect square, 13 is its factor. So each factor is will appear even number of times. Let's just say another number 196. 196 is what? 14 square, and we know 14 is what? 7 into 2. So 2 is appearing for twice and 7 is appearing for twice. So each factor will appear for even number of times. This is that simple. Now let's just move forward. Now see, look at this property. This is very important. If you try to understand its significance, it is saying that the difference between the square of the two It is saying that the difference between the square of two consecutive natural number is always equal to the sum of the natural numbers. Okay. So for example, 41 square minus 40 square. Okay. It is saying that the difference between the squares of two consecutive natural number is always equal to the sum of those number. So sum it, 40 plus 41, and you are getting 81. All right. Now see, now everybody can find the square. Okay, but this property is useful how? Okay, so you can very easily see that if we see this property in reverse, so we will be able to find the number whose square difference it is. So let's just say 42 plus 43 is equals to what? 85. Okay, 85, and you are given 85. Okay, and it is said that it is the sum of two consecutive, it is the sum of the difference of the square of two consecutive numbers. Okay, it is the sum of the square of the difference of two consecutive natural numbers. See guys, try to understand this concept. It is saying the difference between the squares of two consecutive natural numbers is always equal to the sum of the natural number. Okay, so let's just say we have 81. 81 as the uh, 81 as the difference between the square of two consecutive natural numbers. Okay, so definitely we know What is 81? 40 plus 41, two consecutive numbers if we have to find, then 81 is 40 plus 41. Then obviously now you know which number square they are talking about. Now see, this property is useful when used in the opposite direction. That is, given the difference between the square of two consecutive number is 81, you should immediately realize that the numbers are 40 and 41. Okay. So for example, if you had, let's say, 83, 83 as the difference between the square of two consecutive natural numbers. You have x and y as two consecutive natural number, and the difference of their square is what? 83. Okay, the difference of their square is what? 83. So now can you know the number? What are the two consecutive numbers whose addition will be 83? Obviously 41 and 42 you will add, you will get 83. So what is x? 42. What is y? 41. Now you can know any number. Okay, any number. So this is how you can do these. Let's just check for one more number. Okay. Um, let's say we have 101. Okay. Now, which two consecutive numbers? Some can be 101, obviously 50 plus 51. Okay. So definitely we know now the difference of the square of 51 and 50 is 101, and these numbers are 50 and 51. So this becomes that easy for you if you try to remember this property and apply it if possible. Okay. Okay. Now see, um, the square of a number ending in 1, 5 or 6 also end in 1, 5 or 6. So this is very apparent. Okay, so if you do 15 square, you will always get 225. All right. If you do like 6 square, you will get 36. If you do 36 square, okay, then also your last digit will be 6. Okay. So the square of a number ending in 1, 5 or 6 also end in 1, 5 or 6. Okay. Now, see, the square of any number ending in 5, the last two digit will be always 25. Okay, so obviously, when you are taking the square of, let's say, 85, so last two digit you write it as 85, and to find the next two digit, what you will do is take 8 and multiply this by 8 plus 1. So you will get what? 72. So this is the square of 85. Okay, this is the square of 85. It becomes that easy. Now this can be applied anywhere. For example, you have to find the square of 135. Okay, 135. So what you will do? Just write the 5 square, that is 25 here, and then do 13 into 14. Okay, 13 into 14. Now what is 13 into 14? This will be what? 12. Okay, and this will be 5, this will be 3, this will be 1, and you will have 182. So this is how easy you get the square of 135. All right, so any number ending in 5, its square you can find very easily. Any number. Okay, 165 you got, just write 25 and then do what? 16 into 17. So you will get the first two or three digits, and that will be the square of any number ending in 5. So this is also a trick that you can remember. Now let's just move forward to the next section. Okay. Now see, any perfect square will either have end in 1, 4, 5, 6, 9, or an even number of zeros. Okay. So no perfect square will end in 2, 3, 7, or 8, or an odd number of zeros. Okay. You can verify this by list. What we are saying here is, कोई भी परफेक्ट स्क्वायर होगा तो उसकी एंडिंग 1, 4, 5, 6, 9 होगी, और वो 2, 3, 7, 8 नहीं हो सकती. ओके, लेट्स सी वेदर दिस इज एप्लीकेबल टू us or not. Okay, we will see that table. तो इसमें देखिए कोई भी परफेक्ट स्क्वायर है तो आपको एंडिंग क्या मिल रही है, 6 5 6 9। ओके, 1 मिल जाएगा, 2 0 मिल जाएंगे। ओके, 4 मिल जाएगा, बट आपको कभी भी 3 0 नहीं मिलेंगे। 2 3 7 8 आपको कभी भी लास्ट डिजिट ऑफ स्क्वायर नहीं मिलेगा। ओके, so this is all about squares. I hope now everybody will be clear with these concepts. Okay, now see, कोई भी स्क्वायर का जो यूनिट डिजिट है वो 1 कब होगा, जब नंबर जिसका स्क्वायर हुआ है वो भी 1 या 9 में एंड होगा। ओके, सो दिस इज आई थिंक कॉमन सेंस ओनली। जैसे अगर आपको लेट्स से 21 का स्क्वायर किया आपने, ओके, सो दिस विल बी 441। ऑल राइट, दिस विल बी व्हाट, 441। यू कैन जस्ट चेक इट, दिस विल बी 21 21। ओके, ओके, तो अगर कोई भी, if the unit digit of the square of a number is 1, then the number should end in 1 or 9. Okay. तो बेसिकली ये कह क्या रहा है कि अगर आपने किसी भी डिजिट का स्क्वायर किया, ओके, तो उसका यूनिट डिजिट 1 या 9 होना चाहिए ताकि उसका जो एंडिंग है वो 1 पे हो। तो बेसिकली क्या बोल रहा है कि लेट जस्ट से हमने एग्जांपल लिया 21 का स्क्वायर किया। ओके, तो इसका एंडिंग डिजिट क्या आएगा, 1 ओनली। ओके, and this is very easy to calculate because this is 21, so just write 21 and write what, 42 ईयर, तो इसका स्क्वायर क्या हो जाएगा, 441। ओके, तो बेसिकली हमको एंड पे 1 कब मिलता है, जब हमारे यूनिट डिजिट पे 1 हो या फिर क्या हो, 9 हो। 29 का स्क्वायर करके देख लीजिए तो आपका क्या आ जाएगा, 9 9 ज़ार 81, 2 9 ज़ार 18, 18 plus 8 again you will get 26, again you will get 18 here, again you will get 5 here, so this will become what, 841, right, 841। so this is how you calculate some squares। okay, this is, तो आपके पास ट्रिक्स किस किस के स्क्वायर के लिए है, 30 से 50, 31 से 50 के लिए, 51 से 80 के लिए, एंड 81 से 100 के लिए। तो इनकी ट्रिक्स याद रखिएगा और आप आसानी से स्क्वायर निकाल सकते हैं। ऑल राइट, सो आई होप एवरीबडी इज क्लियर विद दिस थिंग। लास्ट प्रॉपर्टी यहाँ पे पढ़ते हैं, इफ द यूनिट डिजिट ऑफ द स्क्वायर ऑफ अ नंबर इज 4, देन द यूनिट डिजिट ऑफ द नंबर इज 2 और 8, है ना। यानी कि अगर कोई ऐसा स्क्वायर है जिसकी लास्ट डिजिट 4 आ रही है, तो उसके वो जो नंबर होगा उसकी यूनिट डिजिट या तो 2 होगी या 8 होगी। चलिए इसको वेरीफाई करके देखते हैं। जैसे 22 का स्क्वायर ले लीजिए। ओके, तो ऑब्वियसली 4 आ रहा है, इसकी यूनिट डिजिट क्या है, 2 है। ओके, इसकी यूनिट डिजिट क्या है, 2 है। और लेट से 28 का स्क्वायर ले लीजिए, तो 8 8 ज़ा 64 करेंगे, ठीक है ना। तो देखिए अगर ये कुछ जनरल ऑब्जर्वेशन कर ले तो हमको बहुत कम कैलकुलेशन करनी पड़ती है। ऑल राइट, ये कुछ जनरल ऑब्जर्वेशन क्या है कि एक तो पहली बात तो 1 4 5 6 9 में ही एंड होगा कोई भी परफेक्ट स्क्वायर, या फिर इवन नंबर ऑफ जीरोस में, है ना। आपका 2378 यूनिट डिजिट नहीं होती किसी भी परफेक्ट स्क्वायर की, ठीक है। 2378 किसी भी परफेक्ट स्क्वायर की यूनिट डिजिट नहीं होती। या फिर ऑड नंबर ऑफ जीरोस भी नहीं होते परफेक्ट स्क्वायर में। देन आपको क्या पता है कि अगर यूनिट डिजिट 1 हो तो या तो नंबर 1 में एंड हुआ होगा या तो नंबर 9 में एंड हुआ होगा। देन क्या है, इफ द यूनिट डिजिट ऑफ द स्क्वायर ऑफ अ नंबर इज 4, देन द यूनिट डिजिट ऑफ द नंबर इज आइदर 2 और 8। इसका मतलब क्या है कि अगर 4 है, स्क्वायर की यूनिट डिजिट 4 है, तो जिस नंबर का स्क्वायर किया हुआ है उसकी यूनिट डिजिट या तो 2 होगी या तो 8 होगी। ऑल राइट, now I hope everybody is clear with these general observation. It will help you in finding the squares. And let's just move here. Okay, now see, if the unit digit of the square of a number is 9, then the unit digit of the number is 3 और 7। ओके, यानी कि अगर किसी का कोई स्क्वायर है और उसकी यूनिट डिजिट 9 है। ओके, तो जैसे 169 है, हमको पता है 13 का स्क्वायर है, तो उसकी यूनिट डिजिट क्या है, 3 है। ओके, उसकी यूनिट डिजिट क्या है, 3 है। जैसे कि 49 है, ओके, तो उसकी यूनिट, उसकी तो एक ही डिजिट है, 7 है, बट स्टिल दिस इज एप्लीकेबल, ऑलराइट, स्टिल दिस इज एप्लीकेबल। एंड देन देखिए नेक्स्ट प्रॉपर्टी, देखिए आप किसी के लिए भी देख लीजिएगा, है ना। अगर यूनिट डिजिट 9 है तो वो या तो 3 का स्क्वायर होगा या 7 का, उसकी यूनिट डिजिट या तो 3 होगी या तो 7 होगी, ऑलराइट। So this is also a general observation. Now let's just move to this. If the unit of the square of a number is 6, है ना, unit digit of the square of a number is 6, then the unit digit of the number is 4 or 6. Okay, so basically ये कह क्या रहा है, जैसे आपने 196 देखा, 14 का स्क्वायर है, तो बोल रहा है कि ये इसकी यूनिट डिजिट या तो 4 हो सकती है या 6 हो सकती है। ओके, आप क्या करिए, 16 का स्क्वायर देख लीजिए, आई थिंक दिस विल बी 216। ओके, हाँ, सॉरी 256, 256, दिस विल बी 256। तो अब देखिए इसका क्या है, यूनिट डिजिट ऑब्वियसली 6 है, तभी ये 256 आ रहा है। सो दिस इज हाउ इट गोज। ओके, दिस इज हाउ इट गोज। तो ये इसको थोड़ा सा ये प्रॉपर्टीज रिवाइज करते रहेंगे तो आपका जो स्क्वायर वगैरह का कॉन्सेप्ट है वो बहुत ही क्लियर रहेगा। एंड ये देखिए, सम ऑफ द स्क्वायर ऑफ फर्स्ट एंड नेचुरल नंबर इज गिवन बाय n+1 to n+1 डिवाइडेड बाय 6, ऑल राइट। तो इसको भी याद रखिएगा। अगर आपको देखिए 1 से लेके 9 तक नेचुरल नंबर के स्क्वायर का सम चाहिए, तो बेसिकली आपको क्या करना पड़ेगा, यहाँ n क्या है आपका, 9, सो 9, 9+1 and what is here, 19 divided by 6। okay, now obviously ये क्या हो जाएगा, ये 3 हो जाएगा, ये 5 हो जाएगा और 19 हो जाएगा, आपका जो भी मल्टीप्लिकेशन का वो आएगा। so that will be the square of the natural number, all right, that will be the sum of the square of first natural number. So this is how we will do these question. Now let's just move forward. See, now the most general thing is that the square of a number is always non-negative. Okay, किसी भी नंबर का स्क्वायर हमेशा नॉन नेगेटिव ही होता है, बिकॉज माइनस माइनस व्हेन यू मल्टीप्लाई यू ऑलवेज नो दैट दिस बिकम्स पॉजिटिव। ओके, चलिए अब देखिए एक और ये प्रॉपर्टी को बहुत अच्छे से समझिए। इट इज सेइंग नॉर्मली बाय स्क्वायरिंग एनी नंबर वी इंक्रीज द वैल्यू ऑफ द नंबर। ओके, and the only time when this is not true is that for the integer 0 or 1 and the numbers between these numbers. Okay, so for example अगर आप 0 का स्क्वायर करें तो आपको 0 मिलेगा, तो वो बढ़ा नहीं। आप 1 का स्क्वायर करेंगे तो 1 ही मिलेगा और वो भी बढ़ा नहीं। एंड अगर आप स्क्वायर करेंगे 0 से बीच 1 के बीच किसी नंबर का, तो उसकी वैल्यू कम होगी। फॉर एग्जाम्पल आप 0.5 का स्क्वायर करेंगे तो वो क्या आ जाएगा, 0.25 आ जाएगा, एंड दैट इज लेस देन 0.5। ओके, इसी तरीके से अगर आप 0.3 का स्क्वायर करेंगे, ओके, तो वो क्या हो जाएगा, 0.09 हो जाएगा। ओके, 0.09 हो जाएगा। तो ये जो बेसिक कॉन्सेप्ट है कुछ आप क्लियर रखिए। ओके, सो दिस इज ऑल अबाउट स्क्वायर एंड इट्स प्रॉपर्टी। ओके, तो अभी देखिए हम जब प्राइम नंबर डिटरमाइन कर रहे थे, जब प्राइम नंबर डिटरमाइन कर रहे थे, तो बेसिकली हम क्या बोलना चाह रहे थे कि हम प्राइम नंबर कैसे डिटरमाइन करेंगे, कि हम क्या करेंगे, 239 ले लेंगे, इसका स्क्वायर रूट देख लेंगे। ओके, तो अब देखिए इसके स्क्वायर रूट के लिए हमको क्या काम आएगा, हमको वो टेबल काम आ जाएगी, है ना, जिसमें स्क्वायर दिए थे। ठीक है, तो मुझे पता है कि 14 का स्क्वायर 196 है, एंड 15 का स्क्वायर 225 है, एंड 16 का स्क्वायर 256 है। ओके, तो ये जो आपका 239 है वो किसके किसके स्क्वायर के बीच आ रहा है, 15 और 16 के। तो मैं इसको क्या करूँगी, 16 अप्रॉक्सीमेट कर लूँगी और 16 के नीचे जो भी प्राइम नंबर है उसकी इससे डिविजिबिलिटी चेक करूँगी। तो अभी 16 के नीचे कौन कौन से प्राइम नंबर है, 2, 3, 5, 7, 11, 13। ओके, 15 is not a prime number, 16 is not a prime number. Now let's just check for this number. Okay, now 2 से तो ये divisible नहीं है. Okay, 2 से ये divisible नहीं है, 3 से भी divisible नहीं है, 5 से भी divisible नहीं है. Because मुझे 9 दिख रहा है तो possibility हो सकती है कि ये 7 से divisible हो. तो देखिए करके देख लेते हैं. तो 7 3 ज़ा 21 करेंगे और ये 29 आ जाएगा. तो बेसिकली नॉट डिविजिबल बाई 7 ऑल्सो. अब क्या पॉसिबिलिटी बचती है, 11 से करके देखें. सो वैसे तो बहुत ही अपरेंटली विजिबल है कि 11 से नहीं होगा, बिकॉज सी 11 2s आर 22. ओके, एंड दिस विल बिकम 19, अगेन नॉट डिविजिबल. द लास्ट चांस इज, लेट जस्ट टेक वेदर दिस इज डिविजिबल बाय 13 or not. So guys, obviously you are not going to get 109 in 13 table, all right? You are not going to get 109 in 13 table because you get 104 in 13 table, all right? So then after that you will get what? 117, and then after that you will get 130, okay? So this is not divisible by 13 also. So basically this becomes a prime number. तो इसके लिए हमको इसके factors नहीं check करने पड़े. We just did this and we got whether it is a prime number or not. So I hope now everybody is clear with this thing, how to check a prime number. And आप इसके लिए एक ये भी condition लगा सकते थे. For example 239 है, so just divide this by 6. What are you getting? Okay, के लिए 239 के लिए preliminary test भी कर सकते क्या? 239 है, divide this by 6. Okay, what are you going to get? 18 times, okay, and this becomes 59, and 6 8s are 54. So obviously you are going to get 5. Now यहाँ से हमको पता चलता है कि पॉसिबिलिटी है कि दिस इज अ प्राइम नंबर. ओके, एंड वही मान लीजिए अगर 257 दिया होता, इसको 6 से डिवाइड करते, सो व्हाट आर वी गोइंग टू गेट? वी आर गोइंग टू गेट व्हाट? 6 4s are 24, all right, and you will be left with 117. Okay, and 6 2s are 12. Okay, so definitely इसका भी क्या रिमाइंडर 5 आ रहा है, तो अब हम इसको चेक कर सकते हैं. ओके, हम इसको चेक कर सकते हैं. हम इसको चेक करेंगे 17 से नीचे वाले सारे नंबर में. ओके, तो अगेन वही सारे नंबर आएंगे 2 3 5 7. Okay, so now you have a method to check whether a number is prime or not. All right, so just keep looking at the square table. 1 to 20 के बीच के स्क्वायर याद कर लीजिए, तो आपको उसके बाद आपको मेथड पता है कि 1 to 30 के बीच के स्क्वायर देख लीजिए अच्छे से. उसके बाद आपको मेथड पता है कि 31 से 50 के बीच का स्क्वायर कैसे कैलकुलेट करेंगे, 51 से 80 के बीच का स्क्वायर कैसे कैलकुलेट करेंगे, और 81 से 100 के बीच का स्क्वायर कैसे कैलकुलेट करेंगे. उसके बाद आप प्राइम नंबर कैसे कैलकुलेट करेंगे, कोई भी है कि नहीं, वो भी आपको पता चल जाएगा. एंड डेफिनेटली ऐसा नंबर दिया होगा जो आप हैंडल कर पाए. ओके, अब देखिए बेसिकली हम क्या बोल रहे हैं कि अगर हम किसी भी नंबर का फैक्टर नहीं फाइंड कर पा रहे, एक्सटेंडिंग दिस लॉजिक, वी कैन से दैट इफ वी आर नॉट एबल टू फाइंड अ फैक्टर ऑफ अ नंबर अप टू द वैल्यू ऑफ इट्स स्क्वायर रूट, we will not be able to find any factor above the square root, and the number under the consideration will be prime number. ठीक है ना. तो बेसिकली क्या बोल रहे हैं कि अगर स्क्वायर रूट तक के नंबर का फैक्टर नहीं फाइंड कर पा रहे हैं, है ना, जैसे हमने 239 देखा था, तो आई थिंक 239 जब देख रहे थे तो 14 का नंबर लिया था. अगर इसके नीचे कोई भी नंबर ऐसा नहीं मिला जो कि इसका कोई फैक्टर है, तो इसके ऊपर भी कोई नंबर ऐसा नहीं मिलेगा जो कि इसका फैक्टर होगा. ओके, इसके ऊपर के फैक्टर से आपको चेक करने की ज़रूरत नहीं है, आपको बस इसके नीचे के फैक्टर से चेक करने की ज़रूरत है. तो ये चीज़ याद रखिएगा. ऑलराइट, ये चीज़ याद रखिएगा. ओके, अब देखिए वैसे तो 49 के बिलो प्राइम नंबर सभी को पता रहते हैं, बट चेक करते हैं वेदर अ नंबर इज प्राइम और नॉट फॉर नंबर्स बिलो 49. ओके, सो देखिए अगर आप किसी भी नंबर के लिए चेक कर रहे हैं बिलो 49, ओके, बिलो 49 अगर आप चेक कर रहे हैं किसी भी नंबर के लिए कि वो प्राइम है या नहीं, तो जैसे एग्जांपल ले लेते हैं 37 का. अब बेसिकली 37 का स्क्वायर किसके किसके बीच आता है, 6 और 7 के बीच. ओके, तो 6 और 7 के बीच आता है तो हम इसको 7 ही रखेंगे। 7 के नीचे चेक करिए तो देखिए 2 आपको पता है 2 से ये डिविजिबल नहीं है, 3 से ये डिविजिबल नहीं है, 5 से ये डिविजिबल नहीं है, ठीक है ना, 5 से ये डिविजिबल नहीं है। इसके नीचे आपके पास प्राइम नंबर है नहीं, है ना, बिकॉज देखिए 2 से डिविजिबल होने के लिए क्या लास्ट डिजिट पे 0 2 4 6 8 कुछ होना चाहिए। 3 से डिविजिबल होने के लिए क्या ये सम ऑफ द डिजिट शुड बी डिविजिबल बाई 3। और 5 से डिविजिबल होने के लिए क्या चाहिए, आपको पता है कि 5 जो है वो लास्ट प्लेस पे होना चाहिए या 0 होना चाहिए। ओके, तो हमको ये पता चल जाता है कि दिस 37 इज अ प्राइम नंबर। दिस बिकम्स सो इजी फॉर अस। तो बेसिकली देखिए 2 और 5 का तो दिख ही जाएगा कि यूनिट डिजिट पे क्या है, तो बेसिकली आपको 3 से बस चेक करना पड़ेगा। और 3 से भी आप कैसे चेक करेंगे, सम करके। ओके, वो उसका डिविजिबिलिटी रूल होता है, हम फिर से पढ़ेंगे, बट आई थिंक इतना कहना काफ़ी है कि अगर कोई नंबर का एडिशन आप कर रहे हैं और वो अगर 3 से डिविजिबल नहीं है तो वो 3 से डिविजिबल नहीं है। इसी कॉन्टेक्स्ट में अगर 36 देखें, आपको पता है ये 3 से डिविजिबल है, इनका सम करिए 9 आएगा, तो ये नंबर 3 से डिविजिबल है, सो इट इज डिविजिबल बाय 3। ऑल राइट, सो दिस इज हाउ यू डू दिस। लेट्स जस्ट मूव फॉरवर्ड। अब देखिए अगर आप 49 से 121 के बीच में कोई नंबर चेक करना चाहते हैं कि वो प्राइम है कि नहीं, तो बेसिकली देख लेते हैं कोई भी नंबर। 53 देख लेते हैं। ओके, 53 देख लेते हैं। तो बेसिकली अगर ये नंबर 53 है तो 53 किस किस के स्क्वायर के बीच में आता है, 7 का स्क्वायर इज 49 एंड 8 का स्क्वायर इज व्हाट 64। सो डेफिनेटली इट विल लाई बिटवीन हियर, तो हम 8 से नीचे चेक करेंगे। सो 2 से डिविजिबल नहीं है, 3 से डिविजिबल नहीं है बिकॉज 5 प्लस 3 इज 8 एंड 8 इज नॉट डिविजिबल बाई 3। 5 से डिविजिबल नहीं है। ओके, 7 से डिविजिबल हमको पता है ये नहीं है, 7 की टेबल में नहीं आता कहीं भी। ओके, 11 से डिविजिबल नहीं है। उसको चेक ही नहीं करना है, क्यों, क्योंकि हमको तो सिर्फ 8 से नीचे के नंबर देखने थे। तो ऑब्वियसली वी गॉट दिस व्हाट दैट दिस इज नॉट डिविजिबल। लेट्स जस्ट चेक 119। ऑल राइट, 119 वेदर इट इज अ प्राइम नंबर और नॉट। ओके, सो वी नो 10 स्क्वायर क्या होता है 100 और 11 स्क्वायर क्या होता है 121। सो वी विल चेक with numbers less than 11। okay, so किससे चेक करेंगे 2 3 5, okay, 7, okay, and the number less than 11 we have to check and those should be prime numbers। okay, so basically 2 3 5 से तो नहीं है, ये आपको पता ही चल रहा है because this is not 0 2 4 6 8। 3 से भी नहीं है because this is what 11 and 11 is not divisible by 3। 5 से तो डेफिनेटली नहीं है, तो सर 7 से आपको चेक करना है। ओके, 7 से चेक कर लेंगे। 7 का बेसिकली क्या है 7 1 7। ओके, एंड देन यू हैव व्हाट 49 एंड 7 7 49। ओके, सो हमको मिल गया कि 7 से डिविजिबल है। ओके, 7 7 49 419। सो दिस इज नॉट अ प्राइम नंबर। ओके, दिस इज नॉट अ प्राइम नंबर। सो दिस इज हाउ यू चेक इट। ओके, इसी तरीके से 121 से 169 के बीच में करेंगे तो देखिए बेसिकली क्या करिए, अगर 0 से 49 के बीच में है तो 2 से डिविजिबल नहीं है, 5 से डिविजिबल नहीं है, ये तो दिख जाता है। तो जस्ट 3 से डिविजिबिलिटी चेक कर लीजिए उसकी। ओके, एंड उसके बाद क्या है कि अगर 49 से 121 के बीच में है, ठीक है ना, तो देखिए ये 77 91 और 119, अगर आप बस इतना याद कर लें कि 49 से 121 के बीच में 77 91 और 119 जो है ये प्राइम नंबर नहीं है, तो सिर्फ आपको 3 से ही डिविजिबिलिटी चेक करनी पड़ेगी, 7 और 11 से भी 7 से भी नहीं करनी पड़ेगी। ऑल राइट, अगर आप सिर्फ इतना याद रख लें कि 77 91 और 119 प्राइम नंबर्स नहीं है। ठीक, इसी तरीके से अगर आप 129 से 169 के बीच की ये बात याद रख लें कि 133 143 एंड 161 आर नॉट प्राइम नंबर, तो भी सिर्फ 3 से ही डिविजिबिलिटी चेक करनी पड़ेगी। दिस इज बेस्ड ऑन द लॉजिक ऑफ दैट मेथड ओनली। ओके, दिस इज बेस्ड ऑन द लॉजिक ऑफ दैट मेथड ओनली। तो कुछ भी ऐसा इसमें नया नहीं है। आई एम नॉट टेलिंग यू एनी ट्रिक, आई एम टेलिंग यू द जनरल ऑब्जर्वेशन दैट पीपल हैव मेड ऑन दीज नंबर्स। ओके, सो बेसिकली 0 से 49 के बीच में आप क्या करेंगे कि 3 से डिविजिबिलिटी चेक करेंगे। ओके, बिकॉज 2 और 5 से डिविजिबिलिटी तो आपको दिख ही जाएगी। यहाँ पे आप 49 से 121 के बीच में कोई नंबर प्राइम है या नहीं, इसके लिए क्या करेंगे, इतना याद रख लीजिए कि 77, 91 और 119 प्राइम नंबर नहीं है। उसके बाद आप 3 से ही डिविजिबिलिटी चेक करेंगे, बिकॉज 2 और 5 से तो आपको डिविजिबिलिटी दिख जाएगी। एंड सिमिलरली अगर आप इतना याद रख लें कि 133, 143 और 161 प्राइम नंबर नहीं है, तो आपको सिर्फ 3 से ही डिविजिबिलिटी चेक करनी पड़ेगी, क्योंकि 2 और 5 प्राइम नंबर है कि नहीं है ये दिख जाता है। ऑलराइट, नाउ लेट्स मूव फॉरवर्ड। So now see, an integer a, इंटीजर्स क्या है ये बेसिकली हमको देखना है। तो इंटीजर जो है वो सारे नेचुरल नंबर्स कंटेन करते हैं 1 टू इंफिनिटी। उनके नेगेटिव नंबर्स जो हैं वो नेचुरल नंबर नेगेटिव नहीं होते, लेकिन अगर हम उनका नेगेटिव काउंटर पार्ट कंसिडर करें तो वो भी इंटीजर्स में इंक्लूडेड है, एंड जीरो इज ऑल्सो एन इंटीजर। सो बेसिकली ऑल द पॉजिटिव नेचुरल नंबर, negative numbers and zero are integer, but they should be not a decimal. Okay, they should be not a decimal. So this is what integer is. Everybody knows what integer is. Decimals we know. Now see, whenever we are writing a decimal, for example 55.1 we are writing, so this is 51 by 10. If we are writing 3.27, so we can write this in another way also, that is 3 plus 2 by 10 plus 7 by 100. ओके, तो जितने दूर ये डेसिमल से होगा उतने दूर ये लगा दीजिए, तो आप इसको इस फॉर्मेट में भी लिख सकते हैं। ऑलराइट, आई होप एवरीबडी इज क्लियर विद दिस थिंग, दीज आर वेरी जनरल थिंग्स। ओके, now, what is a composite number? It's a natural number that has at least one divisor different from unity and itself. Okay. पहले ही बोल चुके composite number जो है it is composed of some number. अब देखिए composite number को, जैसे मान लीजिए 24 है, तो इसके प्राइम फैक्टर्स ले लीजिए P1, P2, जो भी प्राइम फैक्टर्स इसके जितने भी मिल सकते हैं। तो अगर 24 के प्राइम फैक्टर्स लें तो 2 और 3 ही होंगे। ओके, तो 2 का क्यूब और ये, तो बेसिकली अगर हम जितने प्राइम फैक्टर्स हैं उनको इनकी पावर पे रेज कर दें और मल्टीप्लाई कर दें, तो इसको इसका स्टैंडर्ड नोटेशन कहते हैं। वी कॉल दिस अ स्टैंडर्ड नोटेशन। ओके, तो जैसे 84 है, इसके प्राइम फैक्टर्स क्या क्या है, 2 है, 3 है, 7 है, एंड अगर इसको इनकी मैक्सिमम पावर पे रेज कर दें, 2 स्क्वायर इंटू 3 इंटू 7, so this is basically called a standard notation of these. Okay, this is basically called a standard notation of these. I hope everybody is clear with this concept. देखिए, होल नंबर तो और ही सबको पता होता है कि नेचुरल नंबर plus 0 are called whole numbers, and whole numbers are also called non-negative integer, क्योंकि कोई भी negative integer whole number नहीं होता। ओके, सो ये भी डेफिनेशन हमारी क्लियर है। ठीक है, अब देखिए कोई भी नंबर जो रियल नंबर्स हैं वो नंबर लाइन पे रिप्रेजेंट किए जा सकते हैं। ओके, एवरी रियल नंबर कैन बी अप्रोक्सीमेटली रिप्लेस विद अ टर्मिनेटिंग डेसिमल। ठीक है ना। अब देखिए, इररेशनल नंबर भी आपके रियल नंबर्स हैं, बट आपके जो कॉम्प्लेक्स नंबर है वो नंबर लाइन पे नहीं रिप्रेजेंट किए जा सकते। कॉम्प्लेक्स नंबर का क्या होता है, उनको एक कोऑर्डिनेट सिस्टम चाहिए होता है, जिसमें y एक इमेजिनरी एक्सिस होता है और ये एक रियल एक्सिस होता है। तो रियल प्लस इमेजिनरी नंबर को मिलकर के बनते हैं कॉम्प्लेक्स नंबर, उनको नंबर लाइन पे नहीं रिप्रेजेंट किया जा सकता। रियल नंबर को नंबर लाइन पे रिप्रेजेंट किया जा सकता है, ये डिफरेंस है। तो ये छोटे छोटे कॉन्सेप्ट्स को ग्रास्प करने की कोशिश करिए। ठीक है ना। रैशनल नंबर क्या होता है, एनी नंबर इन द फॉर्म ऑफ a बाई b, जहाँ पे b नॉट इक्वल टू 0 है एंड a और b इंटीजर्स होने चाहिए, a और b इंटीजर्स होने चाहिए, तो उनको रैशनल नंबर कहते हैं। सो दिस इज अ वेरी easy definitions. All right, uh, let just study a little bit about divisibility as well. देखिए, a number x is said to be divisible by another number y if it is completely divisible by y. ठीक है ना, यानी कि रिमाइंडर जीरो होगा अगर, तभी उसको completely divisible बोलेंगे. So see this, I is equals to क्यू एन प्लस आर. ठीक है ना, तो Q यहाँ पे क्या है, एक इंटीजर है, n नेचुरल नंबर है, और R जो है वो क्या है, दैट इज रिमाइंडर हैज टू बी अ होल नंबर लेस देन n. हमेशा याद रखिए कि अगर आप जिस भी नंबर से डिवाइड कर रहे हैं, रिमाइंडर उससे हमेशा कम होता है. तो जैसे कि हमने लिया फॉर एग्जांपल 7/2. ओके, तो जब भी हम 2 से किसी नंबर को डिवाइड करेंगे तो रिमाइंडर या तो 0 आएगा या 1 आएगा. इसी तरीके से अगर हमने 3 से डिवाइड किया होता तो रिमाइंडर 0 1 2 में से ही कुछ आएगा. अगर हमने इसको 4 से डिवाइड किया तो रिमाइंडर 1 0 1 2 3 में से ही कुछ आएगा. ऑलराइट, तो इस बात को ध्यान रखिए कि जिस भी नंबर से आप डिवाइड कर रहे हैं किसी नंबर को, सो उसका जो रिमाइंडर है वो हमेशा जिस नंबर से आप डिवाइड कर रहे हैं उससे कम आएगा. ओके, ये कॉन्सेप्ट हम कल भी देख चुके हैं. दिस कॉन्सेप्ट वी आर सीइंग टुडे आल्सो. ओके, सो देखिए, क्वेश्चन क्या है, रिमाइंडर क्या है, ये टर्मिनोलॉजी का उतना मतलब नहीं है जितना ये बात समझने का मतलब है कि whenever you are dividing any number by a number, okay, so what remainder you will basically get if it is not completely divisible will be less than the number by which you are dividing. Okay, the number by which you are dividing. So understanding this concept is very important. Now let's move forward. So I think we have studied too much for this class, and let's just continue in next class. So thank you so much for this class, and keep practicing MCQs for the GS as well and for the CSAT as well, and we will meet in the next class.